So over the course of the last video, we have talked about the Poisson distribution, how we can use it in working on many of the different statistic question. So in this, we will be talking about how to use another distribution, the normal distribution, as an approximation for the Poisson distribution. So basically, for the Poisson distribution, let's just say when mean is very small, when mean is about say 0.5, the graph of its probability looks similar to this. This is the graph. This is so let's just say this is R, and this is the probabilities. The probabilities will look kind of this way. So this is how it might look. Just a representation. So this is probably 1, 2, 3, 4, 5, 6, 7, 8. So this is how Poisson distribution for mean of 0.5 would probably look like. So what if we increase the mean? So let's just say we try to get a higher mean. So let's say mean is now not 0.5. Let's say mean is equal to 25, which is really large. So here we also have the graphs. We have the probabilities and we have the R. So mean here is 25. So a funny thing with the Poisson distribution is that the higher is the mean, the more normal it looks. So when mean is 25, the graph actually looks like this. So the graph looks like this. So it looks really similar to a normal distribution. So which is, yeah, so this is how it's starting to look. So this is the graph of a Poisson distribution with a very big mean, and this is a graph of Poisson distribution with a very small mean. So you may ask, if the mean is very large, can we use the normal distribution to approximate for the Poisson distribution? And the answer is actually yes, that's what we can use. Right, so here is an example of a question where we can use the normal distribution to approximate for the Poisson distribution. So the annual number of deaths nationally for rare disease X is modeled by the Poisson distribution with mean 25. One year there are 31 deaths, and it is suggested that the disease is on the increase. What is the probabilities of 31 or more deaths in a year, assuming the mean has remained at 25? Alright, so here the mean is 25, so that means we can conceive this as a normal distribution. So when the mean is 25, so the mean is now equal to 25, and the variance is also equal to 25. Variance is 25, which show that the standard deviation is root of 25, which is equal to 5. So this is the standard deviation. So we will be treating this the same as the normal distribution. Right, so one year there are 31 deaths, and they are suggested that the decrease is on the increase. The probabilities of 31 or more deaths. Now here a really important concept came in. So we have known that the Poisson distribution is discrete, right? So the R can only take the form of 0, 1, 2, sorry for that, 3, 4, or 5, etc. So it can only be a positive integer. For the normal distribution, the R can take also in the form of, you know, any numbers, so say 3.5 or 6.4. So R can take in this form. So another important concept came in, and it is called continuity correction. So what is continuity correction? Now, so we have that the probability of 31 or more deaths in a year. So Z, so we can get the Z value is to be 31 or more deaths in the year. So probably is 31 or more deaths, which is 31 and 31 or more, so that bigger or equal to 31, right? So 30 bigger or equal to 31 actually started at 30.5, because if it was 30.5, we would round it up to 31. So this is 30. So this is bigger or equal to 31. It's actually not as accurate as saying it bigger or equal to 30.5. So Z here. So the required area will now be changed, be 1 minus 1.1, which is equal to 0.1357. And so you get this this whole value from the normal distribution table, and you can get this is the probabilities that we have 31 or more deaths in a year. The mean remained at 25. So in the case where the mean has come really high for the Poisson distribution, we can actually see it as a normal distribution. And from that, we can get the variance. So, and also remember to apply continuity correction. A lot of time, a lot of students lose mark at applying the continuity correction. And then you get the yes z score, and using the same way where you can find the probability of a normal distribution, you can find the probabilities for that question.